Okay, Assalamualaikum warahmatullahi wabarakatuh. To my panels, Dr. Muzaffar and Dr. Suraya. Okay, today I would like to present my final year project, which titled Development of Visible Light Communication System using Array LED Technique for Wireless Connectivity. Okay, so first, I will start with the project description. So the main goal of this project is to use a red LED as a light source that transmits electromagnetic waves in visible light frequencies so that devices can communicate with one another. The signal will be transmitted using an array LEDs and will be received by OPT101 illumination sensor, which will serve as light sensors to transform the optical signal to an electrical signal. The performance of the visible light communication system will be analyzed under various circumstances such as distance between transmitter and receiver unit and illumination intensity. Okay, so next, the introduction. So the visible light communication technology is currently receiving an unprecedented amount of innovative research in both education and industry. Future devices are likely to need a higher storage capacity, high data speeds, energy consumption, and a better user interface. Optical wireless communication technology, the most recent search, is very appropriate for the future system, including trend-setting innovation and implementation. VLC is a fast and low-cost wireless networking system known as Li-Fi, which refers to the optical and is similar to the Wi-Fi technology. It is predicted and expected to be used in a lot of sectors in industries and human daily life for data transmission in the future. So next I will proceed to the objectives of this project. So the first objective is to design and construct a visible light communication system which consists of transmitter unit and receiver unit by using array LED technique as light source. And the second objective is to analyze the data transmission and performance of visible light communication system under various conditions, such as distance between transmitter unit and receiver unit and illumination intensity. Next, I will proceed to the problem statement. So, current wireless networking technology, which uses the radio frequency spectrum, has many disadvantages and weaknesses, including distortion and high latency problems. The RF technology is also lack of security because there is no privacy as the signal that transmit the data travels through solid surfaces and it can be interrupted momentarily. So next, I will proceed with the methodology. So, excuse me. So the figure on the left side depicts the overall project flowchart, where figure on the right side depicts the working process flowchart. The goal of the project is to construct a system prototype with the help of the Opti system and Proteus software. The prototype will then put through its paces to ensure that the hardware is working and functioning properly. So there are two main components and important things which are needed for this project, which are transmitter unit and receiver unit. So the transmitter unit consists of Arduino microcontroller, array white LEDs, and LED illumination controller. Meanwhile, the receiver unit consists of OPT101 illumination sensor, microcontroller, and PCB. So two computers will be used, one transmitter and one receiver. Data will be injected into the microcontroller from PCA, and the modulated signal will be sent into the array LED circuit. The demodulated signal will be injected out. Carrier signal and message signal are the inputs, and the outputs will be observed. Okay, next. I want to show the results and analysis. So as we can see, the left side is the voltage peak-to-peak signal measured by using oscilloscope on the transmitter. So as we can see, it is a frequency shift keying, and it is almost 5 volt, which is 4.7 or 4.8 volt. Okay, and the center picture is the transmitter unit and receiver unit with 10 centimeter distance. And the right side is the voltage peak-to-peak signal received at the receiver, where it is around 2.5 volt. So as we can see, this is the output from the serial monitor. So if the distance is 10 centimeter, the output can be received successfully without any errors. So as we can see, from 10 centimeter to 40 centimeter, the voltage VPP at the receiver is 2.5. When it reach 50 centimeter, the voltage will become 0.5, and finally 60 centimeter, the voltage will become 0. Okay, so the data from transmitter can be received successfully by the receiver without any error occur when the distance are 10 centimeter, 20 centimeter, 30 centimeter, and 40 centimeters for 6 LEDs. When the distance reach 50 centimeter, there will be some error and data cannot receive perfectly. In order for the data to be received successfully without any error, the voltage received by the receiver must be 2.5 VPP. So next, the illumination intensity is determined by changing the number of LEDs used for data transmission. So we use 2 LEDs, 4 LEDs, and 6 LEDs. So firstly, 2 LEDs were used for data transmission. So from the observation, when 2 LEDs were used, the data can be received by the receiver accurately without any error when the distance are 10 centimeter and 20 centimeter. Error will occur and data cannot be received accurately by the receiver when exceeded 20 centimeter of distance. So same goes to 4 LEDs and 6 LEDs. As the number of LEDs used is increasing, the further the distance of data transmission. So for the conclusion, so based on the result obtained, it can be concluded that the higher the number of LEDs used for data transmission and the closer the distance between transmitter unit and receiver unit, the better the performance of the system. So for the project features, so this project is using LEDs as the light source, and currently fluorescent lamps and incandescent lamps are increasingly being replaced by solid state LEDs. So as we know, LEDs are ideal for their long lifetime, ability to turn on and off at a very high pace, low heat generation, and high energy efficiency. It uses light pulses to transmit data, and at the same time, it can also provide illumination for the users. So for the project potential of commercialization, so VLC is available free for charge for any kind of use. So this project which uses VLC is one of the optical wireless communication where it is viewed as a replacement for traditional RF communication, which operates within a controlled and licensed electromagnetic spectrum band ranging from 30,000 kilohertz to 300 gigahertz. Meanwhile, the optical wireless communication spectral band is operating between 300 gigahertz and 30,000 terahertz. And the best part is that it is free from regulation. So next, I would like to show the demonstration of my project.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Afif Razali. Today I would like to demonstrate my final year project titled Development of Visible Light Communication System using Array LED Technique for Wireless Connectivity. Okay, so this is the transmitter unit, which consists of array LEDs, and this is the receiver unit, which consists of OPT101 illumination sensor. So first I will test the distance between transmitter and receiver with 10 cm. So as we can see from the serial monitor of Arduino, we can see that the data can be transmitted and received by the receiver successfully. Okay, next I changed the distance between transmitter and receiver to 40 cm. So as we can see from the serial monitor of Arduino, when the distance is 40 cm, the data can still be received successfully by the receiver. Okay, next I want to show what happened to the output when distance between transmitter and receiver is 50 cm. So as we can see, when the distance between transmitter and receiver is 50 cm, the data can still be received by the receiver, but there will be some error. Okay, finally, I want to show what happened to the project when the distance between transmitter and receiver is 60 cm. So as we can see, when the distance between transmitter and receiver is 60 cm, the data cannot be received by the receiver.
Okay, now I would like to demonstrate the project. So this is the transmitter part, which uses 6 LEDs, 6 array LEDs, and this is the receiver part. So as we can see here, the data can be received by the receiver successfully. This data is read from the serial monitor from Arduino, and this is the signal from the oscilloscope, reading in the oscilloscope, which stated almost 5 volt, 4.7 volt.